Okay, this is Jack Jackson back. We're in our third of a series of videos talking about circular trigonometric functions. In our previous two videos, we have extended the idea of trig functions so that we no longer have to only allow an input that's an acute angle, but we can actually put in the measure of any rotational angle. And in the case of sine and cosine, they will always be defined for that input angle. And with only a few exceptions, those will be defined for the other functions will be defined as well. Here are the general definitions again, just to review. So we take any rotational angle in standard position, take any point on its terminal side. It doesn't have to be on the unit circle. It could be any point there. Find its coordinates x and y, and then find its distance from the origin r, so that r is the square root of x squared plus y squared. So we're on the circle of radius r. Then the cosine of that angle theta, that amount of rotation that got us to that terminal side, is going to be x over r. The sine is y over r, tangent is y over x, secant is r over x, cosecant is r over y, and cotangent is x over y. So you definitely need to memorize these more general definitions. So everything you see in this box right here, this has to be memorized. And the quicker and the sooner and the better you memorize this, the better off you're going to be. So let's put this to work a little bit in an example here. So here we have a sketch, a tab in our sketch, where we can move this point around, and we can put it on what's called a lattice point. And so if you notice, as this jumps around, it jumps to integer coordinates for point A, and that's going to determine where the and then the circle is going to go through point A, but it's going to have center of the origin, and of course your initial side is on the positive part of the x-axis, which you see right here. So let's take this and say we put it right there. So here's the question. First of all, what's the radius of the circle? What's the equation of the circle? And then what are the values of the 6 trigonometric functions of this angle? So let's see if you can work this one out on your own. Hopefully you can see the grid well enough on the video here. But we're going to pause in a second and do this, and when you get it worked out, come back and we'll check your answer. So press pause now. Okay, coming back, we notice the coordinates on that point are x is 4 and y is negative 3. So x is 4 and y is negative 3. There's the reference triangle right there, and of course the reference angle is this angle right there that always makes with the horizontal. The reference angle will be an acute angle, and the sine, cosine, and tangent of that acute angle will have the same absolute value of the sine, cosine, and tangent of the angle that got us to this point A. So anyway, here are the answers that we have. So we see that it's a rotational angle, and it has a measure of, we'll call it t, okay? And the point where we are is x equals 4 and y equals negative 3. So by the Pythagorean theorem, we determined the radius r, which is the square root of x squared plus y squared, is the square root of, well, it's 5, ultimately. Let's work that out. So r is the square root of x squared plus y squared. X was positive 4, and y was negative 3, plus. So that's positive 16 and positive 9, and then we add up to get 25. And in this case, the square root's easily obtained. It's just 5. So the r is 5 here. So our equation of our circle is always x squared plus y squared equals r squared. The left side are variables, and then we just plug in our number r. R is 5 squared is 25, so it's what's under the square root here. So there's the equation that we're looking for the thing, and of course r is 5 is the other thing we were looking for. Now the next thing we're going to look for is the sine, cosine, and tangent. But notice that we have x equals 4, y equals -3, and r equals 5. And all we need is x, y, and r in our definitions, and we can figure out everything from that. So we just plug in those numbers here. X is 4, and r is, well, the square root of 25, which is 5. So it's 4/5, or 0.8. So sine of t is y over r. So that's -3 over, well, 5. So -3/5, or -0.6. Those are exact values. So generally speaking, this is in a square root because this is dynamic, and a lot of times that square root will not reduce. So the only way to give an exact value is with the square root in it. Now in this case, of course, square root of 25 is 5. It works out nicely. And actually we can divide by 5. Turns out to be a nice terminating decimal. So these decimals are even exact. In general, these decimals will normally be approximations. Now what about tangent? Well, tangent's y over x, so that's -3 over 4, so that's -3/4, or -0.75. Secant is r over x. Remember, secant is the reciprocal of cosine. So you have the co on the sine, you don't have the co on the secant. You have the co on the secant, you don't have the co on the sine. So they kind of, the reciprocal ones, one of them will have co in the front and the other one will not. So that can maybe help keep track of that. But in any event, cosecant is the reciprocal of sine, so it's r over y. That's 5 over -3, so it's -5/3, or -1.6 with the 6 repeating as an exact value. Secant is r over x, so that's 5 over 4, so it's 5/4, or 1.25. And cotangent is x over y, or 4 over -3, or -4/3, or -1.3 with the 3 repeating. Okay, let's try another one. Okay, let's do one. How about that one right there? So see if you can work out the exact values of all the trig functions here. So we're going to determine the radius, the equation of the circle, and the value of the sine, all 6 trig functions for this particular angle, or any angle that rotates and ends up here. They'll have the same trig functions, whether you rotate this in the positive direction, the negative, or rotate around multiple times before you land here. It only really depends on where you end up for that terminal side. Sometimes we'll say this angle is in the second quadrant. That's probably not a really technically correct way to say it, because the angle itself, part of it's in the second quadrant, of course, but the other part's on the x-axis here, and the rotation took us through, say if we did it in the positive direction, took us through all of the first quadrant and part of the second. But of course, when we say that, what we're talking about is where is the terminal side. And the terminal side, except for the vertex, is completely in the second quadrant if we put this in standard form. So sometimes we'll say, where is this angle, meaning where is the terminal side located, and we would say in the second quadrant. And notice that it goes through point A, and you can determine the coordinates of point A, and then figure out the rest of these values that we're looking for. So when you go ahead and work this on your own, come back and we'll check your answer. Press pause now. Okay, coming back, we have an x and y coordinate there, and if you look, the x is -2 and the y is 3. So we have x equals -2, y is +3, and of course then r is the square root of x squared plus y squared. So r is square root of -2 squared plus 3 squared. -2 squared, or 2 squared, either one is 4. 3 squared is 9. 13, and then square root. So square root of 13 is r. It's an exact value for r. It's approximately 3.60555 if you pull out your calculator. But for an exact value, we'll have to use the square root of 13. Okay, so notice now we have an x and a y and an r, And that's all you need, along with the definitions, to find all of the trig functions, or to find the equation for that matter. The equation of the circle is x squared plus y squared equals r squared. R squared is 13. So there's the equation of the circle, with the radius of the square root of 13 centered at the origin. And that circle does go through the point negative 2, 3, and so does the terminal side of our angle. So that angle has measure t, whatever that is, and so we know that the cosine of that angle then is going to be x over r, which is just then negative 2 over square root of 13, and approximately that's negative 0.55470, and the sine is y over r, so 3 over square root of 13, tangent is y over x, 3 over negative 2, cotangent of t is x over y, which is negative 2/3. Cosecant is r over y, square root of 13 over 3, and secant of the t is r over x, so that's the square root of 13 over negative 2. Okay, and you can see where those things turn out, what they turn out to be. There. Okay, so I encourage you to do a lot more problems like this, and so you can practice with this kind of a problem, and of course you can use this sketch. Again, this is an update, so download the sketch again and get into this section right here and practice doing some of these problems. You really want to do it by not looking at the answers, figuring out your answers, and then checking them with this. So ultimately you need to get good enough at this that you don't have to rely on the sketch to do the work for you. You need to be able to do this on your own, but the sketch makes a nice way to check your work. Also, I encourage you, each time that you're doing one of these problems, write down the general definition. Cosine of t equals x over r, then plug in your numbers, and then work out, if you need a decimal, you can work it out on the calculator. But this act of writing down this definition every time will help you memorize it. So I strongly encourage you to do that. Each time you work this, write the actual definition down. Okay, we'll stop there and maybe get some more in another video.